Hello everyone, myself Rajashree Kundu. Today I am going to discuss about the topic classification of signals. So let's start the video. Here signals can be classified in following ways like periodic and aperiodic signals, even and odd signals, analog and digital signals, deterministic and random signals, continuous time and discrete time signals, last, energy and power signals. So, let's talk about the first classification, continuous time and discrete time signals. In continuous time signals, we have continuous amplitude and time. Let's take an example. Here, one signal is varying with respect to continuous time and continuous amplitude also. Next, in discrete time signal, we have amplitude with discrete time intervals. Here, let's take an example. At discrete time intervals, we have amplitude. So this is discrete time signals. Now let's talk about the second classification, analog and digital signals. In analog signals, the analog signals are continuous that vary smoothly over time and can take any value within a range. Here, in this example, amplitude will vary smoothly and continuously with respect to time. Then, digital system or digital signals are discrete in nature, both discrete in time and amplitude, and have binary values for zeros and ones. Then, for an example, here in this example, time t and amplitude, for we have lower amplitude and upper amplitude also. Lower amplitude for zeros and upper amplitude for ones. Then I will discuss about the third classification, which is deterministic and random signals. Deterministic signals can be defined or predicted using mathematical functions. It can be determined from present and past data. Here, it's an sine signal. So, here the mathematical expression is sine omega t. Then random signals, it can't be defined or predicted using mathematical functions. It exhibits uncertainty and randomness in its behavior. Then this is an example of speed signal. After that, I am going to talk about the fourth classification, which is even and odd signals. If you flip the signal and as if it's equal to the actual signal, then we can say the given signal is an even signal. So, even signal follows the following condition: x of n equal x of minus n. Here we have an cosine signal, and after flipping it will become the actual signal. Then odd signal. If you flip the signal, then you will get the negative of the actual one. Here also we have a sin omega t signal. After flipping, it will become minus of sin omega t signal. Then even and odd components of signals. If we have one component xt, then it will become the summation of x even t plus x odd t. Here x even t equal x of t plus x of minus t divided by 2, and x odd t equal x of t minus x of minus t divided by 2. Now I will explain the fifth classification, which is periodic and aperiodic signals. If the signal repeats itself after a fixed period capital T, then it is called as periodic signal. If the component is x of t and if it repeats the fixed time period t, then it will become x of small t plus capital T. So let's take an sinusoidal signal where after fixed duration capital T, it repeats like this. Then if the signal does not repeat itself after only finite period capital T, then it is called aperiodic signal. So here x of t not equal to x of small t plus capital T. Let's take an example of a random signal, which is an classic example of aperiodic signal. Then I will talk about the last classification, which is energy and power signals. If the signal has finite energy and zero power, then the signal is an energy signal, which is denoted by x of t. The equation or formula will be energy E equal integration limit minus infinity to plus infinity x of t square dt. One example of energy signal will be pulse. Then if the signal has finite power and infinite energy, then the signal is a power signal, which is denoted by x of t. Then the formula will be power signal P equal limit capital T tends to infinity 1 divided by t integration limit minus t by 2 to plus t by 2 x of t square dt. Here the example of a power signal will be periodic signals. Thank you for watching this video.